So we're going to go ahead and move on to page 62, which is arithmetic with polynomials. So I'm going to pull up my screen on my document camera so you can follow along on here. I hope that your PDF prints out better than mine did. I'm not entirely sure why the printer and I got into a fight, but that PDF is available to you. So sorry, let me zoom in a little closer. So what I'm going to do first is just work through questions 1, 2, and 3 so that you see exactly what I would do if I was doing these questions. And then we'll talk about the ones that are word problems. So with these, if it's just addition and subtraction, I don't really have a ton of things I need to worry about unless I am subtracting a quantity like we are here. So I do need to make sure that I distribute this negative to both of these. So this would be 4x squared plus 7x cubed minus 10x minus 9x squared. And then since this is plus, everything in this third set of parentheses stays the same. So negative 6x squared minus 7x cubed minus 4x. And I know we've talked about combining like terms before. What we normally do when we are writing polynomials is I go for the highest exponent first. So I have 7x cubed and negative 7x cubed. Those are going to cancel out to 0 and no longer be there. Then I need to look at 4x squared minus 9x squared minus 6x squared. So 4 minus 9 would give me negative 5 minus 6 would give me negative 11x squared. And then I have negative 10x minus 4x, so I'll have negative 14x. And that would be my simplified expression for number 1. Number 2, same thing as number 1, except now when I distribute the negative, this y will become positive. So I'll have y squared minus 7y plus 5 minus 10y squared plus 6y plus y minus 3. So I have 7y squared minus 10y squared, so I'll have negative 9y squared. Then we have negative 7y plus 6y plus y. So that's going to end up turning out to be 0. And then I have plus 5 minus 3, so plus 2. Last but not least, now I'm not just distributing a positive or a negative, but I also have to multiply coefficients and constants. So when I distribute this, 7 times negative 5 gives me negative 35. The x will not change. 7 times 2 gives me plus 14. Here, I'm not just distributing a constant, I'm distributing a coefficient and a variable. So I'm doing negative 3x times negative 5x. I'm going to do the coefficients first. Negative 3 times negative 5 gives me positive 15. X times x gives me x squared. And then I'll have negative 3x times 1, which is just going to be negative 3x. Squared is always going to go first if that's my highest exponent. Then I have to deal with negative 35x minus 3x. I'm getting more negative, and it will be negative 38x x plus 14. And that will be my final answer. Now, when we get into these word problems, one thing I like to do is draw myself a picture because I feel like pictures help our brains the best. So I have a width of x plus 3 and a length of x plus 2. So here's my rectangle. And I've got x plus 3 and x plus 2. And yes, I did write it weird on the side, and I'm going to show you why in just a moment. This is what I'm going to use to think about area, and I'll show you how I'm going to break that down in just a minute. But let's talk about perimeter. Anytime I do perimeter, it's 2 widths plus 2 lengths. So I can create an expression or an equation without even really thinking about the picture of the rectangle because I have this formula. So it's going to be 2 of the x plus 3s and 2 of the x plus 2s. And that's because I have 2 of these measurements and 2 of those measurements. I'm going to distribute the 2's to both parentheses that we have. So it's 2x plus 6 plus 2x plus 4. Combining like terms gives me a perimeter of 2x and 2x makes 4x, 6 and 4 makes 10. Now, that is perimeter. That is all the way around the rectangle. It is very different than area. And I just need to pause this really quickly. All right, so let's talk about area. The way that we are going to think about area for any of these types of problems is what I'm going to do is I'm going to break this rectangle down into smaller portions that talk to me about the area that's happening inside of this triangle. I mean, this rectangle. I swear I know what shape I'm looking at. So here, this smaller rectangle has a length of x and a width of x. So if I want to find the area of this, I do the length times the width, and that will give me x squared. Now I'm going to do the same thing for the 3 other rectangles. This has a side of 3 and a side of x. When I multiply these two things together to talk about this space, I get 3x. If you think back to elementary school when you were learning multiplication and you had that big, gigantic multiplication table, and you took the number on the top and the number on the side, and when you multiplied them together, it gave you the number in that space. It's kind of like talking about area this way, what we're doing right now. So x represents this length, 2 represents this side. When I multiply them together, that gives me 2x. And the last one, 3 times 2, will give us 6. So now I know the area of all of these 4 small rectangles. If I want the area of the huge rectangle, I just add them up together. So I'll have x squared plus 3x plus 2x gives me 5x, and then plus 6. This is the area. I multiplied the length and the width together. And we do that in this visual manner. And everything we do with multiplying these two things together, we are going to do using this. It's called the box method because I am literally drawing a box and using that to multiply my 2 statements together. I do not recommend that you try anything else other than this. So let's go ahead and look at question number 5. Now I have a rectangle that has 2x minus 5 and a length of 4x plus 3. What I want to do here, I'm not going to worry about finding the perimeter. We're just going to focus on area. So I'm going to draw myself another box. And I'm going to put 2x minus 5 and 4x plus 3. I'm going to split this into smaller sections. So now I have 4x times 2x to represent this box here. 4 times 2 gives us 8. X times x gives us x squared. 4x times negative 5 will represent this box here. 4 times negative 5 gives me 20, and the x remains the same. This will be 2x times 3, which will give us 6x. And last, we will have negative 15. Combining like terms together will give us 8x squared. Negative 20x plus 6x gives us negative 14x, and then minus 15. And this measurement is area again. Last question for this. I have the same side, 2x minus 5, but now I have 2x squared minus x plus 3. So now, and it doesn't matter if you do 2x squared minus x plus 3 across the top or along the side. You will end up with the same result in the end. Now instead of 4 boxes, we are going to have 6. So 2x squared times 2x, well, 2 times 2 gives us 4. X squared times x, if you think about your exponent rules, this is technically x to the first. So that gives us x cubed. 2x squared times negative 5 gives us negative 10x squared. Negative x times 2x gives us negative 2x squared. Negative x times negative 5 gives us 5x. 2x times 3 gives us 6x. And then negative 5 times 3 gives us negative 15. Combining all of these together, 4x cubed, negative 2 minus 10 gives us negative 12x squared. 6 and 5 gives us plus 11x, and then minus 15 will be our constant.